Now, so today I'm going to make my fourth review problem video. I made one yesterday. Okay, the one yesterday was on problem 50. These problems here. Yes, correct? Yes or no? Yes. And then the problem review 2 video. Uh-oh. What did that say? 94, what did that say? 87, 88, 94. Isn't that right? Yes or no? Okay. Isn't that what that said there? So, 87, 88, 94. And that, oh no. Did that say 94 there? Could somebody look? Maybe it did. Maybe it did say 94, because we've already done 94. Okay, so we've already done this, so we only have 2 to do. All right, so we only have 2 to do. This one was 70, this one was 70, the third one was 74, 83, 84. I think those, right? I think, right? Yes. So this is problem review 3, right? Problem review 3, that's this one, and the problem review 4. All right? Yes? Okay, so this is the only one we're doing right now. We've done all of these problems. Yes? This is the big guy. It's like 48 minutes long. It's already downloaded. It's already available to you. These I have to load, and then we'll work on this one, and then maybe a couple other problems that I'll do, okay? Yes? Now, that I was going to do next week, but I'll do now. Sabine, everything all right? Sabine, you look pained. Everything all right? Okay, good. So, don't want to be in pain in chemistry. Chemistry is painful enough without bringing pain in with you. Okay? All right? So what I want you to do is put all of your laptops away. Yes? We're going to have all right, put them away. I'm going to do the fact checking. Close them completely. Put the phones away. Okay? Put all the electrons away. Yes? Yes or no? Here is, you can write these numbers down. This is, well actually you don't have to write them down because it's on the video. This is the number in the text, and this is the number in the PowerPoint. That's how that's the lineup. Clear? Yes? Understood? So we're going to be doing 88 to 77. 87 to 76. So it's about 8 to 12 off. Yes.
It doesn't show the top left in the video.
Okay, I'll make that happen. All right. So you can write that down. Well, you don't really. I'll make sure that it's on the film. How's that?
Good.
Look good?
Yeah.
Can you see it all?
Yeah.
Here, I'll tell. I can tell. You can see it all. Good. Okay? So I'll leave that on for a second, and you can access that through the video. Yes?
Yes.
Okay, I have the PowerPoint right here. I've taken the PowerPoint. See, this is how I made the movie, right? Using the PowerPoint, right? So you may be a little tired of looking at some of those movies. So what I'm doing now is, if you go to the Google Drive for the class, there's a new folder, PowerPoint lectures.
But that's like
PowerPoint lectures. In that folder, you'll see the PowerPoints. Like this PowerPoint is labeled chapter problems. Sounds easy? Okay, get it? You with me?
Are you still going to be movies?
Yes, I'm still going to make movies and do all sorts of things. I'm just trying to diversify. Diversification is important. Okay. All right, so let's begin. What number is, what are we doing? 87 is 77, is that what that says?
Yeah.
Okay, I'm just getting to, I have the PowerPoint here, okay? So you have your book, right? So 87, does 87 sound like this? Read to me the first sentence.
Certain gas diffuses 4 times as fast as oxygen. What is the molar mass of the gas?
All right, when we talk about effusion of a gas, what's the rule with effusion of a gas? What's the rule? The denser a gas is, the faster it travels. The heavier a gas is, the faster it travels. The more clever the name of the gas, the faster it travels. The more the noble gases travel, the fastest. Gases that begin with a vowel travel faster. What's the rule for the effusion of gases? Yes?
The motor mass? Like
The more the mass, the heavier ones are traveling faster.
the motor mass.
The molar mass. The greater the molar mass, the faster the gases will travel. Is that what you're saying? Is this your final answer? Yes.
Yes.
Sean.
Gases of lower molar mass will travel faster.
Yes, gases with the lower molar mass. You said the higher molar
No,
mass.
I just said motor mass.
Yeah,
You
you
said
said the higher.
said molar mass.
You said motor mass.
Molar
You
mass.
mean molar mass?
Yeah.
Were you trying to confuse me?
No.
Motor mass, molar mass, that's a
You
little
said
weird.
molar. I said molar.
But you didn't say, they all have molar mass, don't they?
Yeah, but I knew there was something going on with the molar mass.
You knew something with the molar mass.
Yeah, but I wasn't quite sure.
Okay, say molar 5 times really quickly.
Molar.
Motor. Okay, right. Right, get in your molar boat or motor boat, okay? And let's row across, okay. So, yeah, the lighter the gas, the faster it travels, correct? What's the mathematical relationship between the rate a gas effuses and its molar mass? Mr. Miguel, the representative from the great country of the Philippines. Put some points on the board for the Philippines. Can you do it? I'm getting silence. We have a Belgian and a Dutchman. Okay. And a Dutch girl. Okay. Excellent. We have the Dutch and Belgian contingent are feverishly raising their hands. We have a lot of Koreans in here. We have a lot of Angolans. We have a prince of the... What did I say?
There's only one.
Window only.
Yeah, but but it seems like he's more.
It seems like there's 5 of him.
Exactly. Nice recovery or what? Okay. We have a prince of the desert. We do. We have a prince of the desert. We affectionately call him Z-Man. Okay. Yes?
Z-Man.
And yeah, here we go. We got Belgium. Yes. Points on the board. Yes.
There will be rate A. Rate A over rate B equals the square root of molar mass of B over molar.
Exactly. Yeah.
All right. And the lower one, right? The lower one is the one with the lower mass is going to go more quickly. So what gas is going to probably be the fastest?
Helium.
Helium? What's the molar mass of helium?
Hydrogen.
Hydrogen. I am from the UAE. Hydrogen. Okay.
You sound like Russian.
I know. I'm very difficult to do accent of local. It sounds like I'm from Uzbekistan. Okay. Now, I am from Tashkent. Okay. Now, so okay. Now, what is the lightest gas? Helium with a molar mass of 4, or hydrogen with a molar mass of 2? So what's the fastest gas? Hydrogen. Excellent. 1 point for UAE. Okay. They call him Z-Man. Yeah. All right. Now, so. So, what's the only information you're given? What information are you given for this problem? Shall we read the problem?
Yeah.
All right, listen, and you tell me. Let me read the problem, and then we'll discuss it. It says, during an effusion experiment.
What? No.
What number?
87.
Right, but it's 77 here. But doesn't it say during an effusion experiment, a certain number of moles? We're having some technical difficulties.
88 is the during an infusion.
Oh.
In the fusion.
So which one am I doing?
87.
What is it?
87.
So what does that say? A certain gas effuses? Okay, I got you. I'm there. Okay, sorry. All right, I'm there. Okay, sorry. Technical difficulties. Excellent. We've recovered. Laura, you kind of enjoyed yelling at me. You have that look about you. Yes?
I'm about to leave, so.
You're about to, all right, Laura's about to leave, so we have to get started. No more goofing around. All right, Sane? Okay, is there like a land shark on the floor there? You look like something bit your foot off. Everything all right? He's okay. He's all right. All right. Sane Min. They called him Mr. Korea. Excellent. Okay, I like it. Excellent. Yeah, what's the problem, Basil? Excuse me. What's the problem?
No, the answer we're gonna get is here.
But can I read the problem and do it on the board, or what? He's giving the answer away, Baslin? Are you? I know, he's trying to get Jordan on the board. Okay, that's okay. We know your type. Okay.
I don't need to. Yeah.
Aren't you Jordanian?
Yeah.
Well then, what did I say? I said you're trying to get Jordan on the board. Okay, that's all right. That's good. I like the passion. I like it. Competition, man. A certain gas effuses 4 times as fast as oxygen. Yes? What is the molar mass of the gas? So all I have is oxygen, which is, what's the formula for oxygen gas? O2. What's the molar mass of oxygen gas? 32, not 60, 32, 16 and 16. And we know that the gas in question is 4 times more effusive than the oxygen. So what can we say? That this ratio here, this rate, think of it as a velocity, think of it as a miles an hour or meters per second. It's a rate, okay? This rate is 4 times this rate. So how can I represent that quotient with one number? How can I represent it? Isn't it 4 times greater? So isn't the numerator 4 times the denominator? So can I say that it's 4 times greater? That this gas is 4 times greater than this gas? Yeah. So can I just say that this equals 4? Yeah. The left side, this entire quotient is 4. Can I say that? Yeah. Can I? No. Yes or no? Yes. Okay, so this gas is 4 times this gas. Clear? Now, let's rewrite the entire expression with everything in that we need. We know that this molar mass is going to be the molar mass of the faster one, right? But we don't know that molar mass. That's actually what we're solving for. Can't we do this? Watch. That molar mass is the other one. That molar mass is the oxygen, isn't it? So can't we put in there 32?
Yes.
Right? Now can't we put in this 4? 4 over 1, 4 is the same thing, right? Yes or no?
Yeah.
Now, you've done radical expressions? Yes? Okay, so what are you going to do to both sides? You're going to square both sides. You're going to go like this. You're going to square both sides. So that I'm going to square 4, and I'm going to square
I'm doing my thinking voice.
yes or no?
Yes.
Yes or no? Now, you'll also notice now, that the radical expression drops off. This ends up to be what?
16.
16, correct? That's 16? Yes or no?
Yes.
Okay, so I'm going to erase this. Okay? So I know that 16 equals what? 32 over m of a, correct?
Yeah.
Yes or no? All right, so therefore, what can we say about the answer?
It's me.
What's the answer?
2.
2. Ma equals 2. What gas is that?
Hydrogen.
Hydrogen.
Not helium. That's not.
Okay, now now be nice. Okay, be nice, okay? So, all right.
At least
You got it? Do you understand? It's very important. Yes? Easy? Not hard. Yes? Did I go through that well?
Yes.
Okay? All right, let's do the next one. Now the next one is one of the harder problems that I'm having you do. So proceed with great caution. All right? Now, I'm going to read this, and I want you to read it carefully. Sit down, Z-Man. You ready? During an effusion experiment, a certain number of moles of an unknown gas pass through a tiny hole in 75 seconds. Under the same conditions, the same number of moles of oxygen pass through the hole in 30 seconds. What is the molar mass of the unknown gas? Now, listen carefully. This is big. The distance both gases travel could be thought of as equal. Okay? The distance is traveled, correct?
Yes.
Okay, so let me read it again. Okay? T, just hold on for a second. During a effusion experiment, a certain number of moles of an unknown gas pass through a tiny hole in 75 seconds. Now, it's the same number of moles of each gas, correct? Do you understand that? That's important. Okay. Under the same conditions, the same number of moles of oxygen pass through the hole in 30 seconds. Correct?
Yeah.
Easy? Okay. What is the molar mass of the gas? Now, you've got to proceed with great caution here. Okay? You got to proceed with great caution. Because what's the only information that they give you? They give you the time. Isn't that correct? They give you the time. Right?
It can be the rate.
I think you need the rate.
It's, excuse me?
Is it a rate? Like the time they give you?
The time is not a rate.
Okay.
But what are they actually giving you? What is it? What are they actually giving you?
They give you all.
I can't hear you.
They don't give you oxygen. You just tell us the time.
Time would be speed. Well, why don't we do this? This is a really hard one. We're going to turn this off because this is like the last one. So we'll make this number 5, tape 5, okay? So what I want to do is, I'm going to put the information on the board as we were given it, okay? Yes? And then I want to let you work on it for 5-10 minutes. We'll come back and we'll see if we can't come up with some meeting of the minds on how to proceed. Okay? Clear? Is that fair? Okay? All right. So let me write on the board. So what do we have? We have
You have 75 seconds.
what goes in 75 seconds? The unknown?
Unknown.
Okay, so T of unknown gas
Goes 75.
is 75 seconds,
Yep.
right? Okay. How about T for oxygen?
30 seconds.
No, I think you got it. I'm not quite sure. It says during an fusion experiment, a certain number of moles of an unknown gas. Oh, so it is 75 seconds. Okay, and then it says under the same conditions, oxygen goes in 30 seconds. Okay, so the time for oxygen is 30 seconds. Correct? Yes? Yes? Okay. So now let's see what we can do. I think that's it, right? Let me write the equation on the board. Rate of A over rate of B equals molar mass of B over molar mass of A. Now you have to choose what's A, what's B. So we have unknown and we have oxygen, correct? So let's try to work together in pairs, see if we can both learn, teach, present. Understood?
Yes.
Let's go.